Hi, in this lesson, we're going to talk about surds. What is surds? This term may sound unfamiliar, but it's actually quite easy to understand. When we can't simplify a number to remove a square root or cube root, etc., then it is a surd. What we're mainly talking about today is the square root case. For example, square root of 2 is a surd because it can't be further simplified. But square root of 4 is not a surd because it can be simplified to 2. Let's have a look at more examples. Surds are irrational numbers. If we tried to write surds out as decimals, they would go on forever without repeating. That's why we leave them as the surd form. There are two important rules of surds. Rule 1. If multiply two surds, a and b, then the answer is just the same as the surd of the product of a and b. For example, root 3 times root 11 equals root 33. Rule 2. If you multiply a surd by itself, then the answer is just the original number before it was square rooted. For example, root 3 times root 3 equals root 9 and equals 3. How to simplify surds. This is the most important part of this lesson. Simplifying surds is where we rewrite a surd in its simplest form by ensuring the number underneath the root sign, which is called the radicand, has no square numbers as factors. We make the number as small as possible by extracting square factors from radicands. That means to split up the radicands to a product of at least one square number. We can make use the two rules mentioned above, and the knowledge of factor tree method we have learned. Tips. Remembering these square numbers can help us simplify surds much faster. You can pause the video and take a note. Let's try an example, how to simplify root 20. Step 1. Find a square number that is a factor of the number under the root. We know that 20 equals 4 times 5. 4 is a square number. It equals 2 squared. Then we can move to step 2. Rewrite the surd as a product of this square number and another number. Then evaluate the root of the square number. In this case, we rewrite 20 into 4 times 5. Then apply the rule 1, and we get root 4 times root 5. Then continue simplifying root 4 into 2. Hence, the final answer is 2 times root 5. For a larger radicand, we just repeat these steps until it can't be further simplified. Let's try this one. Simplify root 720. 720 is a relatively large number. When we can't find one of its square factors quickly, factor trees can help. There is no essential difference between this process and the factorization of integers, except that root signs are added. Look at the numbers at the end. 2 and 5 are prime numbers. 4 and 9 are square numbers. Then we can rewrite the formula like this. And simplify it in order. Here, we can find a pair of root 2. According to the rule 2, root 2 times root 2 equals 2. Continue simplifying it. Hence, we get the final answer 12 times root 5. There is more than one way to factor 720. If we are a little more familiar with square numbers, we can break it down like this. This time, we can easily extract two square factors, 36 and 4. So we rewrite and simplify the formula like this. We get the same answer. Today, we mainly talk about simplifying a single surd. In the next episode, we will learn about how to calculate the formula with more than one surd. If you have problems with simplifying surds, try CameraMath. You just need to scan the formula and it will provide the detailed solution. It's a good tool to verify whether your answer is correct and check your learning outcomes.